My name is Nan Tran, and today we will be talking about the unicircle and explanations and examples. So first, we will be talking about the degrees on the unicircle. So a full circle is 360 degrees, and the purple is a combination of the red and blue. So red is every 30 degrees, and the blue is every 45 degrees, and purple is above. So 30, 60, 90, or 45, 90, all the way around the circle until you get to 360. And using this, we would take the degrees and multiply by pi over 180 to get the radians that you see on the outside of the circle here. So if you start with 360 times pi over 180 and simplify that, you would get 2 pi or 12 pi over 6, which is 2 pi. So you multiply all these coordinates, you multiply the degrees by pi over 180, and then you simplify your answer until you get the smallest number you possibly can get, and that's your radian. And outside here we have coordinates. So here is 1, 0, because you go right 1 and you don't go up or down, so 1, 0. And then here you have 0, 1, because you don't move left or right, but you go up 1. Same with this, you go left, which is negative, and you don't go up or down, so negative 1. And here you don't move left or right, and you go down, so it's 0, negative 1. And on the outskirts, you have other coordinates, which you can find by using a 30, 60, 90 degree triangle to find the coordinates, such as shown here. So x, so let's pretend the 1/2 and the rad 3 over 2 isn't there yet. So you have x as a small leg, and to find the hypotenuse, you multiply x by 2. So 2x is the hypotenuse. And then to find the long leg, you multiply x by rad 3, which gives you x rad 3. So 1/2 and rad 3 over 2. That's for later. So now that we have this, the radians down, we can move on to SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So the orange here will always be the x-axis, or the cosine, which is why here in the pink, it's where the x would usually be in an xy coordinate. Starting from the origin, you get the xy coordinate because it's going right or left. And the red is sine, which is also y, which goes up and down, and it's in a y position. And blue here, the blue is the radius, and it's 1 because if you go back here, we're assuming that this is a 45-degree triangle, or that's just the most triangle that most pictures use for unicircles. So here, it would be rad 2 over 2 by rad 2 over 2, and to find tan, you would do sine of theta over cosine of theta, or y over x. So if you're doing sine over cosine, you would take rad 2 over 2 over rad 2 over 2, which would give you 1, which is why the radius is 1. Same in this picture, cosine is x, sine of theta is y, and y, the radius is 1, cosine is on the x-axis, and sine is on the y. So the cosine of theta is where the x-coordinate with the terminal side of the angle intersects the unicircle, and sine of theta is the y-coordinate where terminal sides of theta intersects the unicircle. So basically what this means that this angle here is where it's intersecting from the x-coordinate and the y-coordinate here, cosine and sine, which with cosine being the x and sine being the y. and then tan being sine over cosine. So in my example here, we're going to 210 degrees, which gives you a 30 degrees angle from 180, because 210 minus 180 is 30. And then we found the cosine because negative rad 3 over 2 is here in the cosine position, which is also x, and negative 1/2 is y, so that's this part. And that's how we found this, 30, 60, 90. So this is a 90-degree triangle, and this is 30, so we can assume that this here is 60 degrees, so 30, 60, 90, with x equals 1/2 being the short leg, and then 2x, and the long leg being x equals rad 3 over 2. So then you take 2x over 2 equals to 1/2. And these cancel out, and x equals to 1/2. And that's an example of what you can do using a unit circle, but there's plenty more with the trigonometric functions that you can do using sine, cosine, and tan, and the inverse, which is cosecant, secant, and cotangent. Thank you for watching my video today. I hope you enjoyed.